Okay guys, so we are back in our LAB2b, which is a broadcast network over DMVPN. That's the requirement of the exam. Not many companies are running DMVPN right now because most of the security features are going towards the site-to-site VPN. But this is an option. This is what they're testing, so it's good to know about it. Okay, so what we have done already, if you look at the configuration, similar two interfaces, but we have the Ethernet 0x0 is a public interface we mentioned, and what we have mentioned is that we have created a tunnel interface, right? So, and if you look at the route, you will see that I have one static route, default static route towards route number 5, which is acting as ISP cloud. Okay, so now if you look at the tunnel configuration, you will see that we have a static mapping of the remote spokes, right? So we have 4 to 4, 3 to 3, 2 to 2, and then I have NHRP network ID itself. So if you are looking to learn about DMVPN, I have labs for DMVPN on my channel. You can go look at it. I hope that will help you out in understanding what's happening here. So let's go look what we have done on router 2. So if we look at the running configuration, and if I include route, I should have a default route on all the routers, right? All the routers should have a default route. And then if you look at the interfaces, you will see that Ethernet 0x0 is always going towards the ISP, named ISP, and we have a tunnel 1. So if you look at the tunnel 1, this is pointing to all of them. So you see we have a static mapping to all of them. It's not just going to the hub, but it's going to all of them, right? Which it should not be the best way, right? So this, I think we should remove it. We should not have it. We should only have it for router number 1, which is the hub, right? So let me quickly remove it. I think I copied it from somewhere from my previous configuration. So when you copy, you found these mistakes. So let me do that. So now if I look at the tunnel 1, you see that we only have a router 1 information and nothing else. So now if I go to router 3, do the same, show IP route static, we have one default route, then show IP interface brief, exclude assign, we have the same tunnel. If I look into the tunnel, we have these two, so I need to remove here as well. So let's remove it. Let's remove these two, so that we will have only one entry, which is towards the hub, router 1, and then we will have router 4. So let me just remove it first. There we go. We can move these two. So now if we look at the route static, we have one default static route, and then if you look at the interfaces, we have 3 interfaces, and then if you look at the running configuration of tunnel, we have only one entry there as well. So now this is the policy I'm going to run here on the OSPF network. For the OSPF network, R1 is the hub and R2, 3, and 4 are spokes. So that's what we have created. So now if I ping 192.1.2.2 or 3.3, which are the public interfaces, I'm able to ping them, right? So I have public access. Give me a second, guys. Okay, so we have this issue. Then we need to verify that is our tunnel is up, right? So let's ping the tunnel IP, which is 10.1.1.2. So we can ping 2, we can ping 3, we can ping 4. So we can ping the tunnel IP as well. So let's see what do we have DMVPN, because that's a static mapping. So you can see that we have a static mapping here, right? And the same goes to router 2. If you look at DMVPN, we have a static mapping here. If you look at DMVPN, we have a static mapping here, and if you look at DMVPN, we have static mapping. So we have a static mapping all around. So that is fine for us, right? Now if we enable OSPF here right now, then we will see that we have some issues. We are gonna hit some issues. So if you look at the third point, loopback should be advertised with the correct one. So let me fix that too. So if I go in and then I go loopback 0 and I say IP OSPF network point to point, so that we don't have to work on it on all of them. So this is done. So let's and it says the tunnel interface should be configured OSPF broadcast network. So let's do that too. So interface tunnel 1, let's do config all of them. So that's a common configuration. So I will do IP OSPF network. By the way, by default, so if I look at do show IP OSPF interface loopback 0, not loopback 0, tunnel 1, by default is a point to point. Right now there's no OSPF. So let's run OSPF first before we do that. Okay, so let's start OSPF. So let's go to router 1, config T, router OSPF 1, network ID, router ID. Router ID is going to be 1, network, we have 3 networks, right? So we're going to run 10.1.1.1 in area 0, and then we are going to run 1.1.1.1 in area 0, and then and that's it, right? So we have a tunnel, and we have our loopback. So let's do the same here. Router OSPF 1, router ID is going to be 0002, and then network will be 2.2.2.2 in area 0, and then network 10.1.1.2 in area 0. So this is done. Let's go to 3, config T, router OSPF 1, router OSPF 1, router ID is 0.0.3, and then network is 10.1.1.3 in area 0, and then network is 3.2.3 in area 0, and then router 4 will do the same. Quickly, we've finished our setup, and you can see that no matter what I'm doing, I'm not having any neighbor coming up, right? So it means that I have some kind of issue in my node. If I look at show IP OSPF, there's no neighbor, and if I look at show IP OSPF interface tunnel 1, that's a point-to-point interface. Now point-to-point interface, and we know that we are using GRE multipoint. So if you look at the tunnel 1, you can see that we are using GRE multipoint. We are not using GRE IP, which is a point-to-point. But OSPF considered as a point-to-point. So first thing first, we have to change it, right? So we go inside the tunnel 1 and we say IP OSPF network broadcast, because that's what we want. So we did that on all the tunnel for all the routers, right? For all the routers, all the tunnels. So now if we look at show IP OSPF interface tunnel 1, now it's a broadcast, right? So now it's a broadcast, but there's a problem. It's right now it's a state of waiting, but there is a problem. The problem is that for the broadcast network, we have to have a multicast going out, right? So we need to have a multicast running, which right now we are not running multicast. So we need to do something about this multicast thing, right? So if I do this multicast thing, right, so that I want everybody to have a multicast going towards the router 1, and a router 1 has to have a multicast towards all of them, right? Because it's a static mapping. If you look at this, it's static mapping. So we have to have multicast on all of them. So let's do this. So interface tunnel 1, IP NHRP map multicast, and then we have to do the same for all of them, right? So we have to do 192.1.3.3, 2.2, 4.4, right? And you soon it started working. Let's go on router 2. We should do on this side as well. IP NHRP map multicast NHRP map multicast 192.1.1.1. So this is one thing we have to do. Did I write it? No. So router 3 we have to do here as well. But we will see the issue here. What issue I'm talking about. I will tell you in a moment what it's going to be. And then we'll do the same here. IP NHRP map map multicast. What is the multicast? 192.111. That. Okay. So now if I go to router 1 and if I look at show IP OSPF neighbor, now I have the neighbors, and router 4 is a DR. Now you know that router 2, 3 cannot reach router 4. So if I do show IP route OSPF, I'm not receiving 2's network. I'm receiving 4 and I'm receiving 3. So let's go on 2 and let's see what he's getting. He's saying that router 1 is a BDR and he has no information about the DR, right? So we have to somehow disable the election process, and we have to make sure that router 1, which is the hub who knows about everyone, is always picked up as hub. So let's go do that, right? So from all other tunnels, we have to kill the priority. They have to kill the priority. So let's go here. Let's go to tunnel 1 and let's do IP OSPF priority 0. Right. So we are killing. We are saying you are not part of. You are not part of the election process, right? So we are doing this because it's a hub and spoke topology, right? So if we give them this opportunity, they are not going to be part of it. So now you can see that all of them are DR other because they are not participating. In the previous versions, in 12.x version of Cisco IS, you have to reset the process. In the new version, you don't. You can see that as soon as I did, they said that the priority is 0, right? So now if I look at show IP route OSPF, now we have all the routes. And because I have all the routes, router 2 should also be receiving all the routes. And it's receiving it by 3. And this is going to be the same for all of them. So we are not changing, as I said, that we are not changing the next hop, right? In this scenario, in the broadcast scenario, we are not changing it. So if we are not changing it, then let's see how router 2 is going to reach router 3. So if I let's do trace so that we will know where it is going. With the source of loopback 0. Let's see where it's going. Trace route 3333 is not going anywhere, right? Even though we have it in the routing, it's not going anywhere because it's a dynamic. It's not a dynamic process. It's what it says. It's static mapping we have, right? So it's not gonna work, right? And why is that? Let's see. So if I do that, if I do show, if I do ping, can I reach 10.1.1.3? The issue is I cannot reach 10.1.1.3. Right? It's in the tunnel, but I can't reach it. Right? This is the problem we are facing, and that is why we have to map in this, because that address, that tunnel address. If I look at show IP route, I know the 10.11 address. I'm directly connected to it, right? 10.1.1.0. I'm directly connected. It's a tunnel interface, but I don't know how to reach 10.1.1.3, right? So I have to map it. That to reach 10.1.1.3 or 10.1.1.1.4, you need to go through 192.1.1.1. That's the extra work I have to do. So if I go inside tunnel 1 and I have to say IP NHRP map, if I need to go to 113, go to this guy, or even for 4, go to this guy, and I have to do that the same way. So now if I ping 10.1.1.3, it's still not going to work because 3 doesn't know about it, right? So I have to go on to 3 and tell him that, you know what, your 10.1.1.2, you have to send it to router 1, and for 4, you have to send it to router 1, and same way I have to do it on router 4, that if you want to go to 10.1.1.1.2, you have to send it to router 1, and same for 3. So now if I go to 2 and ping again, now I have access because now it's going through. So now if I trace 10.1.1.3, you can see that it's going to 1, right? And now if I trace 3.3.3, with the source of loopback 0, now it's going to 1, and it will always go to 1 because that's how the mapping is working, right? So now we have a mapping, but everywhere we have a mapping of that kind. Now if I look at the NHRP, now you see that for any network, right, my public address is this guy. So public address is going towards hub. This is what I set it up in this scenario, right? And now I can ping 444, I can ping 333. So now we have access to all of them, right? So this is one thing. So we have to what we learned here. Okay, so let's look at the show run interface down one. What we worked here. First of all, we have to have a multicast enabled, right? If you don't have multicast, there will be no neighbor. Second, we have to make sure that whoever is the hub, that hub was chosen as a DR, and all the spokes are never gonna take part in the DR-BDR election. Okay. Now let's move on to the reachability. For reachability to the spokes, we must have the mapping, because we are doing static map. If we have a dynamic map, it should have worked. We should have a mapping to their tunnel addresses through spoke, through hub, right? So that is it, guys. This is a small lab for OSPF broadcast network over DMVPN. I hope you have enjoyed it. I will talk to you soon. Have a good one. Bye.